Hello everyone, thanks for joining the session and hope everyone had a great BTC Pizza day. Before starting our session, we will try to cover a few updates about Bitcoin and Bitcoin mining, which looks interesting to me. So, I just want to cover it in few minutes and then we will start our session. So, the first thing which I was like everyone is using AI. Like if you are an engineer, definitely you are using cloud AI to generate the code, or even if you're not an engineer, you might be using AI tools for making an image, preparing your content, or any documents, right? But this looks very interesting thing in tech that a man who was not able to recover 5 old Bitcoin, which he lost the password a long ago, a decade ago. I think it's 13 years ago. If I will share this link, if anyone wants to read the full, they can read it. So I will share it in the mining session. But I will give you a very brief. Like he has tried everything, but he was not able to find the right password. So what he did, because he has tried everything, he has tried some tools, password tracker and all those tools, but he was not able to do anything. And that 5 BTC, he has purchased it during his college days. So what he has done, he has took his laptop, the college time laptop, and run the cloud AI code and mention everything, like search everything in this whole system, whole drive, and tell me what could be the password which I forgot now for my wallet. So what has happened? Claude checked everything, all the files, all the very old text files, Word documents, whatever he has prepared, and he was looking for it. And then he was able to find it out, the old password which he has created, and the password which he has changed, that he also got to know using this Claude AI tool. And he has mentioned that he will gonna name his son as Claude AI founder's name. So this is a pretty interesting thing I got to know. Like, okay, we are talking about quantum AI and all those things, right? But in this case, AI is also helping us. If you forgot something and if you want to find it out, maybe you can give all the raw data and maybe he will find or guess your old password. Okay, so that is the one news. Another interesting news, because you might be aware, like initially we cover about okay, this solo my blog got mined and all those things, right? But here there is another interesting post. Okay, let me. Okay, so yes, so I'm not sure if it is visible, or let me increase the font size a little bit for this. Okay, so someone just broadcasted 5 transactions, total 107 BTC to this address, to the burn address. Means this 107 BTC, he has just burnt it out. So no one will able to use it. Now, why it is interesting? Because I'm not sure whether you guys are aware of this address. Anyone is aware of like why we are calling, or why Shani is calling this address as a burn address? Means if anyone has any idea or anything. Or is it it was the initial concept for the a burn address, or no? Means why specifically this? Because this is in a hexadecimal number, and if you convert it, it should be 00000 something else, okay? And that is some address which no one is aware of the private key. So this is ideally should be 00000. I just need to double check, and that's why in the hex and all those things it becomes like this. So this 107 BTC, it is not sure whether he has done it with purpose, or maybe he was using some AI tool and that AI tool itself sent it in the wrong address. This could be possible, but 107 BTC is huge amount. I believe he should invest or he should donate it to uh, any good Bitcoin community who is working on education, Bitcoin education, and all those things. That would be much, much better. But I'm not sure the reason. But this was the interesting news I just want to cover. And I remember in the last session, someone has asked, okay, the Bitcoin miners company, all those big companies are moving towards AI. So what are your thoughts on this? So I was just looking at the recent report. So this is a Venic mid-May 2026 Bitcoin chain check. You can read about this blog, but I will just cover a brief about it. If you will go below, you will find it out what are the big players who are mining the Bitcoin. And despite people are pivoting from Bitcoin, when I'm saying people means the big companies are pivoting towards AI, but this is not totally true because if you will see the data, so this is about okay how much percent and all those things. We can leave it for a second, but if you will see this data here, we will see Bitdare, Mara, and all those big players. And if you will see the Q4 2025 hash rate, and this is Q1 2026 hash rate, which is increased by 8.3%. So maybe you might be thinking they are doing partially AI pivot, but they are also investing their profit or money in the mining itself. That's why you are seeing this increased hash rate. Yeah, if anyone has any question or anything, feel free to ask. Let me. Okay. Yeah. So if any one has any question, you can unmute yourself and you can ask because sometimes maybe I will not able to see the um, messages. Okay, so we have covered this. I will be sharing all those three links so you can go through it, read about it, and if you have any doubts or anything, you can feel free to ping me anytime. Okay. Okay. So okay, yeah. Let me see if any question or anything. Okay, not at the moment. So yes, we can move ahead, and we will discuss about the Bitcoin mining stuff. Okay, because in previous session, many of you have requested that okay, just cover how mining works and maybe cover a little bit about more about the block and explain us with taking a raw value and then how the mining hardware works in detail. Okay. For that, maybe first we will cover the basic. I hope the font is visible. If it is not, I would try to increase a little bit. Okay. So, okay, before starting this, we will be doing a very basic analysis of block headers, Merkle roots, and mining mechanism, which we will be using for the Bitcoin network, like how the header will look like and all those things. Then I have also downloaded one JSON file which we will try to have a look, and we'll see if we have to do the task manually. Let us suppose we are the miners manually, how we can do the things manually. Okay. Before starting this, we will just go one by one. Okay. Okay, just give me a second. This I've given the PDF and okay. So every block summarizes its content through a header, creating a fingerprint of all internal data. What does it mean? That the block header, which we will be talking. So what block header contains, we will be seeing, but just block header will be having the fingerprint of all internal data. Because many people have this confusion that along with the block header, we will also include the number of transaction, but this is not correct because we just add the Merkle tree or Merkle root tree, and that is along with all those header components which we will be discussing. Okay, so first, what is mining? So mining is just the process of trying to add a new block of transaction into a blockchain. What is a blockchain? If you will see mempool.space, okay, so it will take, yeah, so this is the blockchain. So keep, this is 951131 block, 1132, 1133, 1134, 1135. So this is a blockchain. And what mining is? Mining is the process of trying to add a new block. So after 1135, there is 1136 will get added. For that, work is already still in progress. And who will do that? The miner will do that, or the mining process will do that. Okay. Anyone have any doubts related to this here, or we can move ahead? Okay. So if no doubts, we can move ahead, and I will also try to write few stuff so you can able to understood this correctly. So I have mentioned that mining is the process of trying to add a new block of transactions onto a blockchain. We have seen this is the blockchain. These are the transaction currently on mempool. Okay. So that means we have to, miners needs to fetch the transactions, right? So what will happen? First, the miner will start fetching the transactions from the mempool, or maybe he is running a node from that it can fetch the transaction. What are those transactions? Just like, okay, I made a payment to someone, you made the payment, and that payment is not yet confirmed. So those payment will be broadcasted and will be there in the mempool. So the miner will fetch those transactions. Sometimes it happens that it will fetch the transaction or it will directly fetch the candidate block. Okay. So I just use a term called candidate block. Anyone is aware of what is candidate block? Or see block? Okay, before candidate block, there is a term called block. What is block? Block, you are seeing it here. So this is one block, this is another block, okay? And every block has two things. So before candidate block, we will cover block. So block has two things. One is block header and then transactions, okay? So this block which has been already mined, it has or it contains the block header, and it also contains the number of transactions which has been already verified. You can see the hash, the timestamp, and all those things, and these are the transaction which already got confirmed or verified. Okay, and it got added in the blockchain. Now, what is candidate block? So you are preparing a next block to be added to the blockchain, right? So that block is not added right now. You will try to attempt and add it to the blockchain. So that is just like a block template you have created or anything, that we call it as a candidate block. So candidate block is a block of transactions which I or miners might at okay might attempt to add to the blockchain. Please interrupt me anywhere, like if you feel like, okay, I did not understand that concept, feel free to interrupt me. I will go slowly, so at least you will be able to understand the things, okay? So now, miner has done the first task, start fetching the transaction from the pool, correct? And then it will start creating the candidate block itself. It may, because it might happen the candidate block is already provided by the mem or uh, the mining pool which you are using. Okay, but doing we are giving all the basics. So in that you can think, okay, let us suppose you are running your own node, you are creating your own candidate block. That is also okay. You can create it, and then after that you can start attempting if the block is valid. So it will get added and it will be a block. Okay, so you start filling the candidate block. So you have created the candidate block. You start, okay, 1 second, let me use it. Okay, okay, or I will use heading. So I will start filling candidate block. And as I mentioned, what candidate block contains? It may contains the transaction. So you will fetch the transaction from the mempool. You will start adding into the candidate block. Okay, and you have to create block header. Now the question would be, what is block header and what are the things would be there in the block header? So I think for this, okay, so we have seen data integrity because of how the block will secure the transaction. Sequential linkage. So each new block reference the one before it, which we will discuss it how it will have. So each block header will have contains the previous block hash. Okay, so everything is linked. Then once a block is mined, it is broadcast to the network where nodes independently verify its validity before adding to the local disk. Means, let us suppose I did some mistake and I started announcing that my block is valid, just add it in the blockchain. But once I start broadcasting to the network, every nodes independently try to verify it, and if it is valid block, then only they will add it, otherwise they will reject it. Now the block header, because which I going to cover, right? So the block header is the most critical part of the block because it contains the previous block, it contains some timestamp, it contains the Merkle root, which we will be discussing it. It will contain the nonce and all those things. So that block header is very, very important, and which we will be doing the hashing. So this is the version number. So version number is also the part of the block header, which will be 4 byte little Indian value. So before going further, I just want to understand whether are you aware of little Indian or big Indian, because here they have mentioned 4 byte little Indian value. That means the version number, if it is 00001, how you will write it. So I will explain you a little bit about big Indian and little Indian, and you will be able to understand it. Zero cross, okay, if it is not, yes. Okay, zero cross. So I'm writing in hexadecimal, okay. So let us suppose this is the number. If I will read it, how I generally read it, I will read it, okay, it has 0 cross 1, 2, it has 0 cross 3, 4. This is the way generally human being will read it, right? But how machine reads it, or how data will go through network. So all those networking devices, like you are using Wi-Fi, you are using Ethernet, you are using 5G, 4G, those devices uses little Indian architecture. Means they will not read it in this way. They will write this thing or store something like this: 7 8 first, then 5 6. So it will read it from right to left, or it will store it from right to left. So this is a little tricky part. Like if you need to see the code and see how these things are working, that thing you will not add it directly. So here, what I'm trying to say is, so this is a JSON format, right? If you will see the version for this, so this is the 1 lakh block, right? The height it is mentioned here. If you will see the version is one, and this is the hex, right? But you might be thinking, okay, once I will cover it, version this, how we will write it and add it in the block header. So it will not write like this, okay? It will write like this: 0 1, then 0 0, then 0 0, 1 2 3, or this way, okay? Means this is how I'm reading it. Once we are giving it to the miner to do the hashing, it should be written like this, okay? This we will be covering it, but I just want to give you a very brief idea how this, because everyone will get confused what is little Indian and big Indian. Like the version number is one, but in the string it should be little Indian, so it seems like 0 1 lakh or something. Okay, so this is 4 byte, which should be in little Indian format. That is the first thing. Okay, so let us start adding it. Okay, I will create this, and this is the version, right? If I need to write it, I will make one here and I will make the 0. So this is the string which I'm creating. Means this is the block header which I'm trying to create. The first which things comes in the field is version, which I have already added. Now I will move back, and if you will see the field 2, it would be the previous block data. Okay, so here maybe I can add it and I can. So for block header, what are the things will be there? Okay, so block header, first thing is version, which is 4 bytes, which is little Indian. Then one thing is done. Okay, second thing is previous block. Okay, I hope this font is visible. Otherwise, because it keeps changing for me. Okay. So previous block, it should be 32 bytes and just natural byte order, how it is written, the same way you have to just add it. So let's go here. It should be there in the previous block somewhere. Okay, so you can see this is the previous block hash. Okay, so the previous block, which will be adding it, then we need to add the Merkle root. So this is the third thing, okay, which will also be 32 bytes. Now, okay, version we understood. Previous block we understood because this is a block hash of a previous block, right? On top of it means, let us suppose if we are making a block 9555136, we need to take a hash of 951135. That's why it's a blockchain, okay? Now the third thing is Merkle root. So now Merkle root, let us suppose we are not aware of. This is how, if you remember, I have mentioned that in the candidate block, you will be adding all those unconfirmed transactions from the mempool, right? For those transactions, you have to do, you have, is Merkle root, you can think is this is just a fingerprint of all the transaction included in the block. Means that's why, if you remember in my previous session, I was saying like, okay, the timestamp will keep changing, nonce will keep changing, and Merkle root will also change because you will shuffle the transactions. You will shuffle the transaction, you can add some transaction, you can remove some transaction. So these hit and try method you can do. You can play with nonce, you can play with, I mean, time it is already keep increasing. You can play with Merkle root. Okay. So, okay, Merkle root. This is the third thing which will be there. Then time. So time will keep changing. So it should be also 4 bytes and Little Indian because everything should be in Little Indian here. And then, so what is this time? Time generally, what is the current time of your miner or the system? It will be keep fetching that. Then you have bits, which is a normal compact representation of current target, and there would be a nonce, which is also 4 byte, which you can keep changing, and that should also be in Little Indian. Means what I'm trying to convey here is, even if you will see the hash, okay, because this is the total hash, you have to make it, but here this nonce, it is written, right? This nonce would be, once you are adding it, you have to first change it in the hexadecimal because this is not in hexadecimal, and then you have to add it in Little Indian format. Okay, so we have added this. Then you have to add the previous block hash, which you've come here. You can see the previous block hashes. Uh, yes, this is the one. So you copy that and put it right now. You can take any here you can see all this transaction which is getting added here. So here from this JSON file, you might need version, which you have already took it in hex. You need Merkle root, which you copy it, but you have to put in order. Okay. So Merkle root will always come after previous block. So let us suppose something is there in previous block. it should be in the same order. Then I have added Merkle root, but see, I'm adding it wrong because if it is written like this, it should be okay. So I can directly copy paste it because this is the hash of or the fingerprint of all the transaction. Then the time. So time it is showing here in decimal. Okay, because it is 4 bytes, but you have to change it into the hexadecimal and then so you can use binary to hexadecimal converter and after that you can change it to the hexadecimal, put it in the little Indian order, time in little Indian order. Then you need to add the bits and the nonce. Once you add it, bits, nonce, which will also be in little Indian. Let us suppose you have added nonce as if it is 4 bytes, it should be eight zeros, right? 1, 2, 3, 4, 5, 6, 7, 8. So this is zero nonce. But if you want to change it to one, it will not be 0, 0, 0, 0, 0, 0, 1. Okay, because it should be in the little Indian order. So once you will be adding this, it will keep change and one will come at the right side of it. Okay. So means let us suppose you are not changing the transaction. So if you are not changing the transaction, what will happen? Nothing will change. Let us suppose time also not change, Merkle root also not change. You have to keep changing the nonce. So people will feel okay. Should I do one this way? No, it should be this way. It should be little Indian. Okay. So if it is 2, it should be this. If it is 3, it should be this. If it is 4, it should be added this. 5, this. 6, this. So if you're just incrementing the nonce and you do the hash to 56, that means if this is the whole string, oh sorry, you will do SHA to 56, SHA to 56 of that block header. Getting my point means if you will see, we are not doing just once because sometimes people feel like, okay, it is just like once and one SHA to 56 and we will get the answer. No, because you will do the SHA to 56 once and then you will do it again. Then you will get the exact hash for that. And if the hash contains all the zeros, that means it is correct. But you will not get like this. Okay. So if you are getting hash, because we know the nonce, right? So let us suppose nonce is this, it should be ideally in the hexadecimal, but okay, let us suppose this is hexadecimal and this is the correct nonce. And you will feel that hash, you will get it like this, but it may be opposite because you will see 0, 0, because you might be getting little Indian and you have to convert it back and then you will find it out and then you will count the number of zeros based on the difficulty. And if it is above the difficulty, it will be treated as a valid block. Otherwise, it will not. One thing I missed here. What is that one thing? That one thing is this Merkle root, when I was explaining, I told you this is a fingerprint of all those transactions, right? But in all those transactions, you have to add your rewards as well, right? Because if you mine a block, you should get some reward. So you have to create a coin-based transaction. In that, you will mention it. So if I will show here, you can go to any block. Okay, so let us suppose I'm going it here in this. Oh, sorry. Uh, Here. Okay, so this is just got added. Oh, okay. So if you will go below, you can see all the list of transactions, right? The first transaction will always be the coin-based transaction. So in the transaction, once you are selecting the transaction from the mempool space to include in the candidate block, which is the list of all the transactions which you want to include, you have to add the very first transaction in a block, which should be the coin-based transaction. And it is because if you are not adding it, you will not get the reward. It is that you are saying that if this block got valid, you will claim the block reward. Okay. So in this case, you can see this Coinbase they have added based on the current 3.1258404 BTC, and they will receive it in this address. If you want to make sure, if you want to double check whether it is for Foundry USA, yes. If you want to check, you can also check it in Arkham. Copy, okay, click here. I can copy this. I can go to Arkham and I can search for this address. And can you see this belongs to Foundry Digital? Okay. So same with others. If you will go to Spider Pool, okay, Spider Pool, and the first transaction will always be the coin-based transaction. If you want to just make sure, you can just copy it, put it here, and you can see this belongs to Spider Pool. So miner needs to add the coin-based transaction first. So the first should be the coin-based transaction, and after that, all those transactions which you got it or received it from the mempool, whatever you want to select, you can select it, and you also need to validate the transactions are valid. It should not happen that miner can add any of the transaction without validation. So you have to validate the transaction, then add it in the candidate block. In the meantime, if anyone has any doubts right now, like regarding this block template which we have covered, or little Indian or big Indian, and how I'm just adding this Merkle root and all those things, feel free to ask. If not, I will move further and we can discuss more about the construction of the block header. Because previous block, Merkle root, and once you are doing the Stratum 56, you don't need to add all those transactions because that is already, you already have a fingerprint of all the transaction in the Merkle root. So you will just do the Stratum 56 of this. Okay. Yes. So anyone has any question, anything they can ask. Otherwise, yes, I can move further and we can uh, discuss. So Coinbase we have discussed already. Then we also need to validate it. That also we have mentioned. Then what are the other things miner needs to do? Okay, so in the means once we are talking about the basic requirements of candidate block. So first we have discussed the first transaction should be the Coinbase. Second, all the transaction you are adding it from mempool, you have to validate it. What is the third? Or anyone is aware of third? Or any wild guess anyone to do? Like it may happen, I have done because every block is getting mined around 10 minutes. It may happen in 10 minutes, I can do 10 transaction, 50 transaction, right? So in that case, you also need to check the parent and the child transactions. So the parent transaction, so the another rule is parent transactions must come before the child transaction. Okay, because it may happen all of my transactions are in currently are unconfirmed because I might have received something, I might have sent something to someone in just a fraction of minutes, right? Or in few seconds. So all the transactions are currently in the mempool. But if a miner is choosing the transaction, it has to first choose the parent transaction. Those are currently in the mempool. And then after that, it can add the child transactions there. Okay, so first should always be the parent transaction, and then later they have to add it. So it should be from top to bottom. So first you include a parent, then after the first the child, the second child means all the transaction might happen after that in a send and receive method, right? And that's why it will not treated as invalid. If you are not doing this way, that means your block is invalid. Okay. So this is the third thing once we are creating a candidate block. Then the fourth thing, any idea on fourth? Like everyone is aware of, there are so many discussion going on for mining, right? What should be the block size, right? Regarding size limit, right? So size limit is also there. Like if there is a certain weight unit, your candidate block, including the size of block header, which should be in, I think, 320 weight units, along with all those transactions, it should not go above uh, the specific unit, right? So that is the fourth important thing which miner needs to be aware if it is creating the candidate block. But let us suppose if you are not doing solo mining, you might be using any, or even if you are doing solo mining, you might be using any mining pool which might be creating a block for you. Then you don't need to worry about these things because these things are already taken care by uh, that mining pool. But if you are doing everything from scratch, you have to make sure the transaction selection which you are doing is accordingly based on parent child method. Now, another important question sometimes people ask, can miners mine the empty block of transaction? Means let us suppose uh, like they have just added only two transaction or three transaction. Will it possible? Yes, because whatever the things we have discussed, I do not recall the block, but let me try. There was it to something. Anyone is aware of that empty block? which does not contain any transaction, because it will be containing that point-based transaction, so it will be already one. So logically, you cannot say that there should be empty block. But there was one block, there was no such transaction, only coin-based transaction was there. Let me search it on Google. Just give me a second. Uh, okay, it was this, I guess. Let me. Okay, can you see? This is the means ideally it will not be empty because there would be one coin-based transaction, but you can see there's only one transaction, which is a Coinbase. So uh, practically, I can say that there is no transaction is added in this block. Okay. So if anyone is asking you, can miners mine empty block of transaction? Yes, they just need to add the one Coinbase transaction. Otherwise, they will not get the reward. And if they are able to find the block hash which is above the difficulty level, yes, that will be treated as a valid block, and um, you will get your reward. Okay, so that is still possible at the moment. Okay, because things may get changed later, but at the moment it is possible. Even if because maybe if you might be aware of the CLI things, right? There is a Bitcoin CLI. You can use it, you can run your own node, you can get the block template from that. So if you have made your customized miner and you just want to get the block template, there are already certain CLI which you can use, and you can ideally get the block template and you can just start mining it. Like one command, you can simply type Bitcoin CLI and you can ask for get block template. And maybe you can also add some rules, and there are some parameters. Maybe if you will go to GitHub, you will get to know. But this is the general command which you use, and you will able to fetch the transaction from the node which is currently the unconfirmed transaction, which is already there in the mempool. And then you can use those transactions to create a candidate block. Sure. So I hope you got the basic idea, the block header and all those things which we have discussed right now. So everything would be having this. Block header also have a fixed size, and the number of transactions depends. So there is a maximum limit of a block, and you can create less transaction as just like we have seen that block which only contains one transaction. Okay, so let me see if I forgot to cover anything. So okay, Merkle root we have covered it. Uh, yeah, verification structure, data commitment we have already covered because the Merkle root is the part of the header. And if you are changing the transaction which you are adding, the Merkle root will always get changed because this is the fingerprint of all those transactions. So it will keep changing if you are changing and shuffling even if you are shuffling the transaction means, let us suppose you have added four transactions, 1, 2, 3, 4, but if you just shuffle the third with fourth, fourth with third, then also Merkle root will get changed. Time stamping. The time stamping is not in your hand, but it will keep changing because this is a dynamic variable, right? It will keep changing. So you have a 4 byte which will keep changing, and that can also help you to find a um, hash which is more than the above difficulty. Okay, target difficulty. Bits we have discussed, that is also 4 byte. And for the current mining target, then another one we have discussed about the nonce, which is also 4 bytes, and it should be in little Indian format. And you can change this thing. You can go from 0 to 1, And if you have four miners, you can divide the nonce among four miners, and maybe one miner will try from 0 to 10, another 10 to 20, another 20 to 30, just for example. Okay. Then, yes, transaction count, roll block payload. So 80 byte header size. Yes, this we have already covered. Coinbase, yeah. So the first you have to add the Coinbase one, which should be the first one, and then you can add whatever there. Then, yes, first you have to add the parent, which we have already discussed. You have to do the validity check. You also need to make sure the parent is getting added first and all those things. Block weight and all those things, yes. So 80 bytes is the header size, so it is already fixed. The number of transactions would get changed, but total limit is this. So block header plus the number of transaction which you are adding, it should not get above that. But as this is already in discussion and everything, this is keep changing, right? So earlier it was the size was very small. Now it got bigger, right? And then there is a separate knot and this core. So this we have, yeah. So let me see. Yes, this we have also. You have to set version previous has as we have created it here, just like the whole string kind of thing you can think of. And then once you pass it into the start of 56, and you can see this is the whole thing with nonce and one start of 56 function, whatever you will get, again start of 56, and that is the real hash. Okay. So if you will just simply use the sort of 56 function and you will try to do it manually, it will not work. Okay. Then if it is working, you just validate it once, and after that, you just start broadcasting it. If you feel that it is above the target difficulty, then difficulty adjustment, yes, 10-minute average. If you will see here, it is already mentioned because right now the average block time is 9.9 minutes, which is less than 10 minutes. So definitely the difficulty will get increased in just 2 days if it is keep happening in 9.9 minutes. Okay. So yeah, that's all from my side. If anyone has any question, any queries, I hope in this session, uh, this block header and how this mining works in just a simple format, at least you will able to get it, and what are the components would be there, and how miners will keep shuffling those things and got to find the hash which is more than target difficulty. So yeah, that's all from my side. If anyone has any question, anything, feel free to ask. I'm gonna share the links on the mining channel, and I will also see if I can add this rough notes. I can prepare it, like I can just put it in AI and maybe prepare a better local thing, and then maybe I can add it in the mining channel. So if anyone might have missed it, they can also see the recording and they can also go through that notes or the PPT, which I will be sharing on the mining session. So yeah, anyone has any question, any doubts so far, or anything which maybe you are not able to understand, feel free to ask. If no, then yeah, go through it. I will share some of the links, and even if any doubts later, you can also ask or ping me anytime later as well.